Right, so again, remember, we're finding the shortest distance from a line to a point. It's got to be perpendicular. We make it perpendicular by getting the dot product equal to 0. Okay? There we go. The dot product equal to 0. So, let's try a couple others, okay? I'm not going to do all 4 of these, but let's try part B here, okay? We want the shortest distance from point Q, which is -1, 1, to the line that has the parametric equations x equals t, y equals 1 minus t. So notice they gave us the parametrics in this case.
But couldn't you find
Okay.
the forms for the not parametric?
Yeah, you could. The equation that these parametrics would have come from would be xy equals, where's our starting point?
0,
0,
1,
1 plus t times
1,
1 negative 1, okay? 1 negative 1. That would have been the vector equation. Here, they gave us the parametrics, okay? So now we want to find r, and we're going to make r have what coordinates?
T and 1 minus t.
Good, t and 1 minus t. We use the parametric equations for the coordinates of r.
And then dot product, so you said it equals 0 and solve.
Well, hang on. We don't have actual vectors yet. Okay? We do need to identify what was the velocity vector of the line we're talking about. What's our velocity vector? You guys should be able to pick this up by now really fast.
T plus
1 negative 1, okay? The velocity vector is always the one multiplied by the time, the parameter. So 1 negative 1 is our velocity vector. We also need a vector here from Q to R, okay? Because we're getting a vector from the point that we're talking about to the line.
T plus 1.
So t, good, t minus a negative 1 is t plus 1. Okay, 1 minus t minus 1. Okay, so yeah, that's just going to be a negative t when we simplify it. All right, so we have t plus 1 and t.
So just reverse them.
Okay. What do you mean?
They reverse the parametric equations.
Oh, in this case it happened to be, but
Yeah, don't bet on that one.
don't bet on that every time. It's only because q is -1, 1.
Why is it not negative T?
Oh, it is. It is, sorry. Okay, so there's our QR. There's vector v.
Now we can solve.
Now we can dot product, okay? Doesn't matter the order. T plus 1, negative t, dotted with 1, negative 1, has to equal 0, because the shortest distance will always be measured perpendicularly, okay?
It's -1.
All right, so we dot product. T plus 1 times 1 is t plus 1. Negative t times negative 1 is positive t. We want that to equal 0. We subtract 1, divide by 2, t equals a -1/2. Good. Okay? So that's the time when point Q is the closest to the line. Now, do note here, they ask for the shortest distance. Okay? So have we answered the question at this point?
Is it the magnitude of the vector?
Those of you paying attention, have we answered the actual question here?
500 later.
So we have to then find what that vector is from Q to R. Now we know the time, so now we can actually give the actual point. R is -1/2, 3/2. Okay, that's the actual point R. The actual vector QR is -1/2 plus 1 is going to be 1/2. And negative t is a positive 1/2. Okay? So, how would we find the distance if that's our vector?
Magnitude.
Magnitude. Okay? What is the magnitude of QR? Alright? So we've got our Pythagorean theorem. 1/4 plus 1/4. Okay? We've got the square root of 1/2. Which is √2/2. That's the shortest distance from Q to that line.
Oh, because you would say
Okay.
-1.
1/2 squared plus 1/2 squared, square rooted. Okay? Any questions? Okay. All right. We might come back and do one more if we have time at the end, but I want to look at one of these in a more true-to-life situation. Yeah.
How did you get for just the kind of equations, how did you get
The vector equation? Well, remember that if you look at this vector equation, if I were trying to find the parametric equation, I would have x equals 2 plus s times 1. Okay? That's what x would equal. So since x here equals 0 plus t, that t is multiplied by 1, so that's why I have a 0 here and a 1 there. Okay? And then same thing here. The 1 goes here, this minus 1, that's why I have a minus 1 there. All right, so let's look at a case here, and in this case too, we are not given the equation of the line. All right, we've got to think through how we would figure it out when we're not given the equation of the line. So let's look at the whole situation here. Here we have this, this origin, 0, 0, that's placed on here, and all the distances are in kilometers. So 8 kilometers to the west and 3 kilometers north of our origin is point A, and 10 kilometers to the east and obviously it's not drawn to scale, 2 kilometers to the north is point P. Okay? And what it says here is that ship R is moving in the direction 3, 4 at 10 kilometers per hour. Now question, is this, does that have a magnitude of 10? No, what's its magnitude? Its magnitude is 5. 3, 4, 5, Pythagorean triple, okay? So think with me, if this has a magnitude of 5, is that the velocity vector of ship R?
No. 6,
No. What should it be?
6, 8.
It should be 6, 8. This has a magnitude of 5 kilometers per hour. Okay? So in order to get 10 kilometers per hour, the velocity vector has got to be 6, 8. To double the magnitude, I've got to double the components of my vector. All right? So that's one thing to be careful about. It didn't say that this was its velocity. It said this was its direction. And then this was the magnitude. All right? That was that part right there, though, if you don't see, the whole thing gets thrown off. All right? Now, another thing I would recommend, they intentionally didn't draw it this way because they wanted R to just be an arbitrary point. But as you're drawing this, the point we're looking for is going to be perpendicular, is going to be the point where PR will be perpendicular to the line AR. Okay? But before we can find that, part A says that we need to write an expression for the position of the ship in terms of T. Okay? So, the position of the ship, we can call XY. We're writing a vector equation here. Where was the ship's starting point? What? Good. It started at -8,3. Okay, so that's our position vector relative to the origin, -8,3.
The velocity vector is 6,8.
Our velocity vector is 6,8, so it's plus
T,
t times
6,8.
6,8. Okay? So there is the expression, or the vector equation, really, for the position of the ship in terms of t. At this point, we're actually back to where we were on the last two examples. Okay? We have the equation of a line. We have this point. What are we going to express point R to be? What's the x-coordinate of point R?
-8 plus 60.
Good. -8 plus 6t. All right? It would be the x parametric equation. If you want to write out the parametric equations, go right ahead, if that helps. Okay? The y parametric equation would be
3 plus 18.
3 plus 8t. So that's going to be the y coordinate of point R. 3 plus 8t. So what's next?
Find the vector.
Find what?
Find the vector from P to R.
Find the vector from P to R. Okay. The vector from the port to that point R is
-8 plus 16 minus 3.
minus the 10 from the x-coordinate of P. Remember, it's the x-coordinate of the point you're going to, which is R, minus the x-coordinate of the point you're coming from, which is point P. Okay? And then, what's our y component, our vertical component?
3 plus 18 minus 2.
Okay, 3 plus 8t minus 2. So in the end here, PR is the vector -18 plus 6t and 1 plus 8t. Okay? Are there any questions about how we got PR or how we got to this point? The rest of it is the same every time. It's pretty simple, okay? But you got to be able to get to this point. All right. So what is our next step? Good, dot product. And Alina, what does the dot product need to equal?
0.
To 0. Good. So we're going to do the dot product with PR and with that velocity. See why it's important to get that velocity vector? Okay, 6, 8. So it's dotted with the velocity. So we have negative 18 plus 6t times 6 plus 1 plus 8t times 8. And that has to equal 0. So now we've got an equation, we're back in Algebra 1, and we can solve it, okay? Negative 18 times 6 is going to be 108, negative 108, plus 36t, plus 8 plus 64t, and that's got to equal 0. So we've got 100t, and that's going to equal 100 if I get it, the numbers on the other side. So t has to equal 1. All right? And did we answer the question?
Yeah.
Yes, because they're asking for the time. So 1 hour after leaving the port at A, 1 hour is going to elapse here before we'll be the closest we could be to point P. All right? All right. Now, I gave you some practice here. Okay, here's the one with 3 dimensions. It's the same principle. Okay, it's the same principle. We would find the vector from here to this line. Okay, we would also identify the velocity. The velocity here would be 3, 2, 1. Look at the coefficients of t. All right? And then we would find the vector from 3, 0, negative 1 to a random point on that line, which we use the parametric equations for. So we're going to dot that with the vector 2 plus 3t minus 3, negative 1 plus 2t minus 0, and 4 plus t minus a negative 1. We dot these together, set it equal to 0, and you've got the same thing. It's just in 3D now. Okay, so the principle is the same. All right. I gave you a little bit of practice to try, just a couple of them. You could do that. On Monday, we'll take questions, we'll practice mixed problems about vectors, and then we'll also do a little bit more prep Tuesday before we start, and then we'll do your test the second half of the period. Okay? All right.